So the next question is, again, what is the total charge of a, right now we're not gonna do a balloon shell, but we're gonna do a solid sphere. Solid sphere. Solid sphere. So again, we have the same idea that we had before. We have this circle, and let's add some depth to it. And we can put also the Cartesian axis just to have a feeling where we are in the wall, right? X, Y, and Z. And what's different from the previous question is actually right now we don't want a sticker on the shell of the sphere. We want something with thickness. We want this kind of thing. If this is what we had previously, we want also to have a Lego brick, right? So we can actually put all the pieces together and build a complete sphere. Okay, so that's what we actually want over here. So how are we going to do it? So we talked about this before in the previous question. What is the surface of this one? We said that this one is actually from here to here is moving al d theta. Sorry, now it's not going to be a capital R, it's going to be small r, right? D theta. Why small r? Okay, right now I'm going to take a Lego brick that can be anywhere. If this is the middle of the circle, of the sphere, so this is the end, so I can take a piece from here, from here, from here, from here, from here, from many, all the way until I reach to the end. So my final radius is going to be big R, capital R, but in between I have many R's. So right now I'm going to use L d theta. And this angle as before is r sinus theta, which is, you know, the projection of this shape here, and I move some angle phi, so d phi, this is theta, right? And also, what I want to pump it up, this thing, right? So this length is actually dr. So that's the idea. So right now we have a volume. And I didn't tell you, but the charge density of this sphere is the simplest that you can think of, is a constant, which means rho equal to rho 0, which means constant, no variables, which means in this location, whatever you want, there's the same charge. Okay, there's the same charge distribution. In this piece of brick of volume, in this one, everything is the same. So, what is the volume? What is dV? dV is equal to the multiplication of all of these, you know, the height and the base. So the height is dr, and the base is this one, which is r squared sinus theta, d theta, d phi. So this is the volume. If I want dq, what I need to do? To multiply rho 0, rho 0, multiply by this, dr, r squared sinus theta, d phi, d theta, d phi. Okay, perfect. So let's clean this part. And now, what we really want is the total charge. And something really interesting happened here. Look. So if I'm going to solve this, okay, it's dq, and we say the dq is equal to rho dv, and this is my dv, this is my dq, this is my dv, right? This is rho, but this is a constant, which means I can take this one outside of the integral, right? And then what I'm gonna have rho integral of dv. And what is this term? This said sum all the small bricks, the Lego bricks, the small volumes in order to build the sphere. So if you already know what is the volume of a sphere, you can have a shortcut. You can say, dude, I know this one is equal to 4 pi r to the third over 3. And you finish the question without solving the integral itself. You actually knew what the result should be. And one can actually take this thing, take this out, put the integral of r to be 0 till big R, theta to be from 0 to pi, and phi to be from 0 to 2 pi. And you're gonna get the same answer. So you actually save time. So what I want you to do, if you see that you have a constant distributions, right? So I want you to think, maybe I know the shape. Maybe I remember it. Maybe it's a pyramid, maybe it's a sphere, maybe it's a, I don't know, a box, whatever it is. If you already know it, you can save time. This is the idea of this question. So right now, guys, you're ready to do your homework. And this was the last question. Now you can also handle the sphere questions. And the idea of this tutorial was to teach you the different coordinates that we have, how to use them, and what is the difference between them, and how to develop this thing, which is the division. So remember, as we did all the time, what you need to do is divide and then obtain the integral. That's it. It's really simple. So guys, good luck with the first homework, and see you next week.